All right, let's dive into one of the most incredible rhythmic processes happening in your body right now, the journey of a single heartbeat.
I mean, you can feel it, right? That classic lub-dub. But what is actually going on in there? Turns out it's not just a simple squeeze. It's a perfectly timed ballet of pressure, volume, and valves. And get this, the whole performance, from start to finish, happens in just 0.8 seconds. Yeah, less than a single second.
In that tiny sliver of time, your heart completes an entire cycle of filling up with blood and then powerfully launching it out to your entire body. The precision is it's mind-blowing, really.
And that's what we're talking about today, the heart cycle. It's the complete story of one single beat, and we are going to break it all down step by step.
So to wrap our heads around this, the best way to think about it is that your heart is essentially a two-stage pump. It has two fundamental modes.
And those two modes are called diastole and systole. Diastole, that's the chill phase. It's when the heart relaxes and fills up with blood. And systole, that's the action phase, the contraction that pumps all that blood out. So just remember, relax and fill, contract and pump. That's the basic rhythm of life.
Okay, but here's a cool little twist you probably wouldn't expect. You'd think the big, powerful pumping part would take the most time, right? Nope, it's actually the other way around. Diastole, the filling phase, takes a whole half second, while systole, the big squeeze, is a super fast 0.3 seconds. It just goes to show you how important that relaxation and filling time is for the heart to do its job right.
So let's start right there, with that all-important filling phase. How exactly does the heart load up its chambers for the next big push?
Well, it's a two-part process. For the most part, about 80% of it, blood just flows in passively, kind of like pouring water into a glass. But then, for that last little bit, there's a final active push called the atrial kick to really top things off.
So here's what's happening with the plumbing. The main doors between the upper and lower chambers, the AV valves, they're wide open. But the exit doors, they're shut tight. Blood just pours down into the ventricles, and then the atria give that last little squeeze. The whole goal here is to fill those ventricles up as much as possible, which gives us a super important measurement called the end diastolic volume, or EDV for short.
All right, the tanks are full. Now for the action. Let's get into the squeeze, the part where the heart builds up all that pressure to send blood rocketing through your body.
And just like the filling phase, this part, systole, also has two main steps. First, you've got to build the pressure, a lot of it, and only then can you actually eject the blood. The second those ventricles start to squeeze, the pressure inside just skyrockets. And that intense pressure immediately forces those inlet valves, the ones the blood just came through, to slam shut. And that noise is a really big deal.
This kicks off this really fascinating moment called isovolumetric contraction. Okay, isovolumetric just means same volume. For a split second, all four valves in the heart are sealed shut. The ventricle is squeezing like crazy, but the blood has nowhere to go. The pressure just builds and builds. And that sound of the AV valves slamming shut, that is your first heart sound, S1, the lub in lub-dub.
So once the pressure inside gets high enough, higher than the pressure in the arteries outside, the exit valves, the semilunar valves, are literally blown open, and whoosh, blood shoots out into the aorta and the pulmonary artery. The amount of blood that gets pushed out is called the stroke volume, and the little bit that stays behind, that's the end systolic volume.
Okay, the pump is done, but we're not finished yet. Now the heart has to reset itself to do the whole thing all over again, and it has less than half a second to do it.
Now, as the ventricles start to relax, the pressure inside them just plummets. This means the pressure in the big arteries is suddenly higher, and it tries to pull blood backward into the heart. And to stop that from happening, the exit valves slam shut.
And this brings on another isovolumetric phase. But this time, it's for relaxation. So once again, all four valves are closed tight. The ventricle is relaxing, but the volume of blood inside isn't changing just yet. And that sharp snap of the semilunar valves closing, that's your second heart sound, S2. That's the dub. So lub is the start of the pump, and dub is the start of the reset.
So now we can put the whole story together. Because those sounds, they aren't just random noises. They are the actual acoustic signature of a healthy, working heart.
Which brings us back to our big question from the beginning. What really is that lub-dub sound that your doctor's listening for with a stethoscope?
It's not the muscle contracting, not really. It's the crisp, clean sound of your heart's valves slamming shut at exactly the right moment to make sure blood only ever flows in one direction. It's the sound of perfect timing.
And this table just nails it down. That first sound, the lub, that's the AV valves closing as the big pump begins. The second sound, the dub, that's the semilunar valves closing as the heart begins to relax and refill. That is the literal soundtrack of the heart cycle. And what's absolutely amazing is that scientists can actually visualize this entire mechanical journey, all these changes in pressure and volume, on a single beautiful graph.
It's called the pressure-volume loop, and it shows every single phase we just talked about. See this bottom line here? That's the ventricle filling up. Volume goes up, but pressure stays low. Then, bam, this vertical line. That's our isovolumetric contraction, where pressure just shoots to the moon. This top curve, that's the ejection phase, where volume goes down while pressure is high. And finally, this other vertical line shows the pressure plummeting during isovolumetric relaxation. The whole 0.8-second story right there in one elegant loop.
More than 100,000 times every single day, without you ever having to think about it, your heart performs this perfect, life-sustaining ballet. It really makes you stop and wonder, doesn't it? What other amazing things is your body doing for you right this very second?